The size of the universe is one of the most profound and enigmatic questions in modern science. Despite centuries of inquiry, the true scope of the cosmos remains elusive, largely due to the inherent challenges of observing distant regions and making sense of the data we collect. The vastness of the universe stretches beyond the limits of human perception, instrumentation, and theoretical models, requiring astronomers to piece together clues from indirect evidence. This involves interpretations and a large dose of guesswork, it must be conceded, regarding, for example, the redshift of light, the cosmic microwave background CMB radiation, and the distribution of matter across vast scales. After watching popular science shows and listening to the usual suspects, you might be left with the impression that we have a good handle on all of the stuff going on out there. But do we? Quote, "The public has a distorted view of science because children are taught in school that science is a collection of firmly established truths. In fact, science is not a collection of truths. It is a continuing exploration of mysteries." Close quote, Freeman Dyson. In the beginning. James Ussher was the Archbishop of Ireland between 1625 and 1656. He was a prolific scholar, most famous for his chronology, which sought to establish the time and date of creation. He calculated it at around 6 p.m. on the 22nd of October, 4004 BC. While this might sound amusing today, we should remember that another member of the Catholic hierarchy, Georges Abbé Lemaitre, conceived the Big Bang. Lemaitre, a Belgian priest, was also a gifted mathematician. He is famous for his description of the beginning of the universe as a day without yesterday, in reference to the creation account in Genesis. George Gamow, some pronounce it Gamow, another famous Big Bang proponent, described the graphs of conditions in the Big Bang as divine creation curves, and sent a copy of his book, The Creation of the Universe, to the then Pope. Although this archaic religious concept can claim to be the dominant cosmology right now, it is not without its critics. Hannes Alfvén, for example, the father of plasma physics and plasma cosmology, was blunt in his appraisal. Quote, "I was there when Abbé Georges Lemaitre first proposed this theory. Lemaitre was, at the time, both a member of the Catholic hierarchy and an accomplished scientist. He said in private that this theory was a way to reconcile science with St. Thomas Aquinas' theological dictum of creatio ex nihilo, or creation out of nothing. There is no rational reason to doubt that the universe has existed indefinitely for an infinite time. It is only myth that attempts to say how the universe came to be, either 4,000 or 20 billion years ago." Close quote. The electric universe is a broad synthesis that continues the work of Alfvén and others, emphasizing the role of plasmas and electromagnetism on the cosmic scale. While Thornhill, the co-founder of this contemporary movement, was more succinct. Quote, "They deride creationism and in the same breath promote the Big Bang." Close quote. According to mainstream physics, the law of energy conservation states that matter cannot be created or destroyed, only converted from one form to another. The Big Bang, however, contradicts this principle by proposing that matter emerged at a fantastical rate from nothing. To sidestep this issue, proponents argue that the laws of physics began with the Big Bang. It's a classical case of circular reasoning, of course. Please note that I am neither deriding nor promoting the notion of a creative intelligence behind the universe, or an intelligent universe, whichever way you look at it. That is a separate philosophical argument beyond the scope of this discussion. It should be noted, however, that the electric universe, a connected living universe, can accommodate many ideas without resting on them. Fred Hoyle coined the term Big Bang. He did so disparagingly, but it stuck. The term turned out to have a simple and memorable elegance, unlike the actual hypothesis, which, it has to be said, is a collection of tenuous claims and interpretations. When Einstein met Georges Lemaitre in 1933, he said, quote, "This is the most beautiful and satisfactory explanation of creation to which I have ever listened." Close quote. So, it seems the Big Bang does have some merit after all. Artistic merit. The prophetic versus the actualistic. Following in the footsteps of their renowned predecessors, plasma physicists embrace an actualistic approach to science, working backward from observation and adopting a broad perspective. Christian Bjerkeland, for example, valued experimentation and direct observation over mathematical modelling, despite his training as a mathematician. He gained fame for his Terrella experiments and expeditions to the polar regions, where he studied the auroras firsthand. Big Bangers, by contrast, exhibit a preference for the prophetic approach, that of starting out from idealized mathematical principles and selectively interpreting data to fit. This theoretical approach, however, is fraught with problems, as the history of science testifies. Quote, "In the beginning there was nothing, which exploded," close quote, Terry Pratchett. Surviving for centuries, Ptolemaic epicycles were mathematically elegant, and they enabled the prediction of planetary motions, but they failed to reflect the underlying mechanism. Mathematical proofs were also cited to support the claim that heavier-than-air flight was impossible. There are numerous amusing examples throughout history, some of which we cover in Misconceptions Part 3, Where's the Math? Nonetheless, many still refuse to recognize the limitations of math-driven cosmology. We are talking hubris vis-a-vis humility. Quote, "It is ironical that, in the very field in which science has claimed superiority to theology, for example, in the abandoning of dogma and the granting of absolute freedom to criticism, the positions are now reversed. Science will not tolerate criticism of relativity," close quote, Herbert Dingle. It has been argued that traditional empiricism, classical science, based on observation, hypothesis, testing, and theory, has been replaced by theoretical physics, sometimes jokingly referred to as math magics, in the light of its many historical failures. Adding weight to this suspicion, Stephen Hawking appeared to admit to as much. Quote, "You really can't beat a good mathematical theorem," close quote, he summed up. CMB, Cosmic Microwave Background Radiation. Big Bang supporters are fond of claiming CMB radiation, which they interpret as the heat signature left over by the sudden expansion, as conclusive evidence for their theory. But these claims begin to look somewhat revisionist in the light of the following facts. The background temperature of space was predicted by several scientists, based on a universe without expansion and before the discovery of the CMB. Their predictions were far more accurate than Big Bang models. This excellent peer-reviewed paper outlines the true history of the CMB. Quote, "In this paper we show that other models of a universe in dynamical equilibrium without expansion had predicted this temperature prior to Gamow. Moreover, we show that Gamow's own predictions were worse than these previous ones." Close quote. In 1965, two young radio astronomers, Arno Penzias and Robert Wilson, accidentally discovered the CMB using a small horn antenna. This discovery was quickly commandeered by Big Bang supporters, who later awarded them a Nobel Prize. There are alternative interpretations, including but not limited to the plasma model. Quote, "The CMB is a radio fog of dense plasma filaments," close quote, Eric Lerner. Lerner wrote the best-selling Big Bang Never Happened, in which he predicted many of the findings now confirmed by the James Webb Space Telescope, JWST. If Lerner is right, the CMB tells us nothing about the age and size of the universe. In part 4 of this Misconception series, I mentioned Wikipedia's failure to document the real history of CMB predictions. They have recently added some historical background, but nothing substantial to challenge the Big Bang narrative. Some years ago, I added this to their CMB page for balance. However, a senior editor removed it, dismissing all challenges to the Big Bang as fringe science. He even confessed that peer review is insufficient for inclusion. Instead, Wikipedia prioritizes secondary sources, often mainstream media. You have to laugh. I said then, and I say again, in my humble opinion, the actions of Wikipedia represent bad faith and historical revisionism. As it stands, anyone reading the Wikipedia page on the CMB might come away believing that it provides irrefutable evidence for the Big Bang. The extragalactic universe. Edwin Hubble is a pivotal figure in modern astronomy. His most celebrated achievement came in the 1920s when he established the existence of galaxies beyond the Milky Way, the extragalactic universe, thus overturning the prevailing belief that the Milky Way comprised the entirety of the cosmos. Known as the Hubble law, within an expanding universe framework, it is assumed that the redshift of distant galaxies is primarily due to the Doppler effect, an increase in the wavelength of light caused by rapid recession. Mathematicians seized upon this idea, extrapolating backward to a hypothetical point of origin, which became the foundation of the Big Bang theory. However, Hubble termed his famous discovery, quote, redshift versus apparent distance relationship, close quote. Rather than signifying that some faint galaxies are accelerating away from us, Hubble maintained that some new physics was probably involved. How often do you hear this from doctrinal scientists? Galaxies have also been shown to have widely varying brightness, rendering ineffective the astronomical measurements known as standard candles. Holton Arp, a famous student of Hubble, further researched and developed his mentor's reservations about redshift interpretations. Arp compiled the Atlas of Peculiar Galaxies, which documents numerous galaxies that do not fit with an expanding universe. Many high redshift quasars, quasi-stellar objects, appear to be physically connected to low redshift galaxies, challenging the conventional view that redshift is a straightforward indicator of distance and velocity. Our proposed alternative explanations, suggesting that redshifts might reflect intrinsic properties rather than solely cosmological expansion. The Electric Universe subscribes to Arp's thesis. As reported by this channel, quasars are ejected from active galactic nuclei AGN and can evolve into companion galaxies. In this case, the highly redshifted objects indicate their youthfulness. The evidence which Arp and others began presenting several decades ago includes impossible connections between high and low redshift objects. This image of Stephan's quintet, for example, shows a quasar with a redshift of 10 billion light-years from Earth in front of the galaxy NGC 7319, which has a redshift of just a few hundred million light-years. In another telling example, back in 1971, the Mount Palomar telescope discovered a luminous bridge between the low redshift galaxy NGC 4319 and the much higher redshift quasar Markarian 205. This also contradicts the assumption that redshift is invariably a measure of velocity and distance. Orthodox astronomers fiercely resisted this evidence, together with numerous other examples that have been either suppressed or ignored. Flash forward to October 2002. The Space Science Telescope Institute issued a press release picture of NGC 4319 and Markarian 205 with the bridge removed, implying that it never existed. Quote, of course, if one ignores contradictory observations, one can claim to have an elegant or robust theory, but it isn't science. Close quote, Holton Arp. Quasars and quasi-science. When we look at a spiral galaxy, in addition to quasars, we also see companion galaxies distributed away and along from the axis of rotation, apparently coalescing from the ejected matter. Occasionally, there are visible bridges connecting them. These bridges are plasma filaments, of course. JWST images vindicate ARP's contention. Quasars further from the parent galaxy have lower redshifts, and, moving away further still, he observed dwarf and prototype galaxies with still lower redshifts. The implications are clear. Galaxies are born and die in a living, connected and cyclical universe. Contrast ARP's observations with the Big Bang model, where everything allegedly began in a miraculous creation event, yet is now seen as random, disconnected and purposeless. It's a bizarre dichotomy. Quote, "Give us one free miracle and we will take care of the rest," close quote, Terence McKenna. ARP is sometimes described as a modern-day Galileo. The title of his last book, Seeing Red, is a clever wordplay. A continuation of his redshift research, it also hints at his anger after being cast out by the scientific establishment. After being denied telescope time in the US, he moved to Germany to continue his work at the Max Planck Institute. No wonder ARP compared big science today with the church of old. From chapter 10 of Seeing Red, quote, "This is far from the first time this parallel has been noted. The Church, still in Galileo's time, was the ultimate authority on the most important matters. After the ideals of the Enlightenment and the heady rise of astronomy and physics, however, we have the present-day situation where all authority in natural law has passed to science. In return for important and profound pronouncements on the nature of the universe, academics are supported with high salaries, expensive facilities, travel, prestige, and lifetime security. They also bestow the power of this institution onto successors of their own choosing." Close quote. The dwarf galaxy problem. Also known as the missing satellites problem, the dwarf galaxy problem arises from a mismatch between the numbers observed and those predicted by Big Bang models. Although there seem to be enough normal-sized galaxies, the number of dwarf galaxies is orders of magnitude lower than expected from cosmological simulations that predict the evolution of the distribution of matter in the universe. Kipu, the largest structure in the universe? An enormous structure has just been discovered. This colossal formation, an intricate network of almost 70 galaxy clusters linked by immense filaments, stretches 1.4 billion light-years across. Named Kipu, it takes inspiration from the knotted cords used by the ancient Incas to record information, mirroring its branching filamentary appearance. According to the Big Bang, structures of this magnitude shouldn't exist. The universe was thought to be homogeneous on its largest scales. Kipu defies that assumption. Even more intriguingly, it may extend beyond the zone of avoidance, a region of space obscured by the Milky Way's dust clouds, suggesting that its true size could be even greater than currently observed. The James Webb Space Telescope, JWST. In addition to huge galaxy structures like Kipu, numerous mature galaxies in the so-called early universe have been discovered, a revelation that is not so much problematic for standard Big Bang cosmology, but outright impossible within its framework. The unexpected abundance of these well-formed galaxies at the supposed, quote, dawn of time has sparked such profound challenges that at least one scientific paper has even proposed doubling the hypothetical age of the universe. Referred to as a grand design spiral, the most striking and well-structured class of galaxies, the Zulong Galaxy, for example, has been captured by the James Webb Space Telescope as it appeared 12.8 billion years ago, merely 1 billion years after the hypothesized Big Bang. Its existence suggests that a Milky Way-like galaxy must have formed nearly 10 times faster than current theories predict. While Thornhill's prediction that astronomers would resort to adding additional epicycles in order to postpone the falsification of the Big Bang is proving depressingly accurate. Quote, "The only problem is that discovery doesn't change anything," close quote, Walt Thornhill. If galaxies as large and developed as those observed were already present so soon after the Big Bang, then the 13.8 billion year age estimate begins to look little better than Archbishop Usher's 4004 BC claims. Quote, "Since religion intrinsically rejects empirical methods, there should never be any attempt to reconcile scientific theories with religion. An infinitely old universe, always evolving, may not be compatible with the Book of Genesis. However, religions such as Buddhism get along without having any explicit creation mythology and are in no way contradicted by a universe without a beginning or end. Creatio ex nihilo, even as a religious doctrine, only dates to around AD 200. The key is not to confuse myth and empirical results, or religion and science," close quote, Hannes Alfvén. In summary, the JWST raises profound questions about the age and size of the universe, not to mention the mechanisms driving its evolution. Conclusion. By pushing the boundaries of observation and refining our theoretical frameworks, we inch closer to unraveling the true scale of the cosmos, but its ultimate size may forever elude comprehension. This points to a deeper issue in cosmology. Our models are based on assumptions that shape how we interpret data. This begs the question, are we discovering reality or imposing it? If you were expecting an answer to how big is the universe, then I'm sorry to disappoint you. While there are many out there who might try and sell you uncertainty, the reality is that we have no idea. Quote, "So the universe is not quite as you thought it was. You'd better rearrange your beliefs because you certainly can't rearrange the universe," close quote, Isaac Asimov. The position of the electric universe and plasma cosmology is that there was no Big Bang. The universe is of unknown age and extent and possibly infinite. In the next episode of the Misconception series, Part 7, we look at another common question. How do plasmas conduct electrical energy in space?